Hi, this is Jason Gorman from Codemanship, with the first in a series of videos aimed at JavaScript developers to explain this practice called test-driven development. You may well have heard of it, you might have tried it. Now, as the name implies, test-driven development is driving the design and development of our code using tests, specifically using tests as specifications, and you'll see how that works in this example we're going to do now. So in this video, we're going to look at the basic steps of test-driven development. There are three. We're going to look at how we write tests that fail, which can act as specifications for our code. And then we're going to look at how we do the simplest thing we can think of to pass each test. And we'll also be looking at how we refactor the code once we've passed each test, so that going forward it's as easy to understand, as simple, and as maintainable as possible. So those three steps: write a test that fails, write the simplest code to pass the test, and then refactor the code if necessary to make it easier to change later. Now, I'm going to be using a shopping basket example. So our requirement, our business requirement, is to calculate the total of items in a shopping basket. And we're going to do this in a test-driven way. So traditionally, unit tests have been written after the solution code that they're testing. But in test-driven development, we actually start by writing the test first. So I'm going to be testing using a framework called Mocha. So let's install that using npm. It'll take a little while there. So we're going to be using Mocha to write tests for shopping basket totals, or totalizing if you like. And what we're going to do is we're going to start by writing the simplest test case we can think of, the simplest example of a shopping basket total we can think of. But before we do that, we've got a bit of yak shaving to do. Mocha by default will look for a folder, a subfolder in our project called tests. So let's create a subfolder to put our tests in, and it's going to look in that folder for any JavaScript files that end with _test, and it'll try to run any tests that it finds in those files. But first of all, we need to tell npm that's what it needs to do. So it's going to run the test task here, test script, using Mocha, and then it will look in this test folder for any JavaScript files ending in _test. So let's create a test file for our shopping basket that ends with _test, so that Mocha knows that it's a test file. Okay, now, if you're new to Mocha or unit testing frameworks in general, then I strongly recommend that you pause the video here and actually go and take a look at Mocha, because without that, what's happening next is not going to make a lot of sense. So pause the video here, and there's a link to the Mocha webpage in the description below. Okay, now that we're all hopefully on the same page with Mocha, let's write a Mocha test. In this case, a test fixture. And we're going to name it after the thing that we're testing. So we're testing the shopping basket total. And for our first test case, what we're saying is it is 0 when the basket is empty. That's the simplest case I can think of, an empty shopping basket. So it should be very easy to pass. Okay, let's first of all create our empty basket. Just an empty array will do. Okay, now what we're going to do is we're going to retrieve a total from. Now, here's the whole crux of test-driven development. We need a function that calculates the totals, that totalizes, if you like, the shopping basket. But this function does not exist, and this is the way round that it works in test-driven development. Such a function does not exist, but let's imagine that it does. What would we need in order to get that total? Well, we'd need something like that. And you can see already that my IDE is already complaining that totalize doesn't exist. There's no such function. Um, so here's the golden rule of test-driven development. This is really what it's all about. We don't declare solution code unless we have a failing test that requires it. So at this point, I can give myself permission to declare this totalize function. Let's make it global there. Okay, so I can declare this function here and use it in the test, but we use it in the test first, and that forces us to declare it. That's the whole meat and potatoes. That's where the rubber meets the road in test-driven development. Clue is very much in the name. And finally, let's ask a question about what that total should be. So we'll assert that the total is equal to, well, it should be 0 because the basket is empty. Okay. Now, when I run this test, it should fail. Oh, there's a little thing I have forgotten to include there, which is I need to import that assert for Mocha. Otherwise, it's not going to run. Okay, now let's run the test, see what happens. Lovely, yeah, it's expecting 0, but at the moment when we're returning undefined, there's nothing happening here. So let's do the simplest thing we can think of to pass the test. Well, it's just that. It only needs at the moment to be 0. Now, this is very, very important. Some people, when we demonstrate test-driven development for them in this way, we just return 0, they complain and they say, well, that's obviously not the total, is it? We obviously haven't totaled it. It's absolutely fine. What we've done here is we've written a test that has forced us to make a couple of design decisions. We've forced us to declare this totalize function, and we're saying that it takes the basket as the parameter and it's returning a number. Okay, it's returning a total. So we made 3 design decisions at the end of this test, and the test is passing. It works for what it is. It works for an empty basket, basically. Now, before we move on from this passing test, we need to take a look at the code that we've written. I'm not convinced that this total constant here is actually really adding any value and how readable this test is. I think the name of the function actually explains what's going on here. So what I'm going to do is I'm going to inline that, and that's going to remove the constant and replace it with the actual value. Now, I've just performed a refactoring. I've changed the code, so theoretically it should still do what it did before, but it's been restructured slightly. And what I need to know as soon as possible after I've done a refactoring is, does that still work? If I've broken it, obviously I want to know as soon as possible. And it hasn't, it absolutely worked. So I immediately rerun my tests after the refactoring. So there you go. We've done one little microcycle there of test-driven development. We wrote a failing test that described what should happen when the basket is empty. What should the total be when the basket is empty? We made a small number of design decisions in our solution code, and we did the simplest thing possible to pass this test, and then we did a little bit of refactoring to clean up the code a little bit. Now, this basket constant here, I think, is adding some value, because if I inline that, then it's just going to be an empty array, and then we know, what does that empty array represent? So in order to make it more obvious what that little bit of test data there means, what role is it playing in the test, I've given it a name, and I think it's going to stay with that name. Okay, now let's move on to a second failing test, because they're not all going to be empty baskets. So is basically the unit price of a single item in the basket. So when there's only one item in the basket, the quantity of that item is 1, then we're just going to return the unit price. Okay, so rinse and repeat. Basically, we need a basket. This time this basket has got 1 item in it. So let's create that item there, and let's give it a unit price. Say, for example, 10, and a quantity. Okay, and the quantity is 1. Okay, and we have our totalize function, so we can use that in our assertion. So if we total this basket, we should get the price of that individual item. Of course, at the moment we won't. What we'll get when we run it is 0. It's expecting 10, but it's actually 0. So now we're back at another failing test, and we want to do the simplest thing possible that will pass both of these tests. Well, now, if the basket is empty, there's nothing in it, then that first return value is still going to work. But if the basket's not empty, then what we need to do is just return the unit price of the only item in the basket. Let's just do that. Okay, so when we rerun our test, they should both be passing. Nice and easy, nice and easy. Okay, now we're back at a passing test. Our code is working. So before we move on, we need a little code review. Well, there's something that's been bugging me. This code here is not part of the test code. It's actually solution code. It doesn't belong here. So before I move on to the next failing test case for our shopping basket, I'm going to extract this code into its own module. So let's first of all give it somewhere to go. And we can call this the shopping basket. Will make nice sense. So it's obvious what's going on in here. Now, okay, I'm going to have to do this as a single step. So let's remove that code. Let's cut that code. Let's import the totalize function from our shopping basket. Okay. And then let's paste it into here and export it. Okay, so theoretically, when we go back to our tests now, it should be all passing. There you go. So there's another refactoring that we did. So now our test code and our solution code is separate, which is as it should be. Right, I'm reasonably happy with what we've got so far. So I'm actually going to move on to another failing test. Okay, let's take another step forward. So it's going to work for a single item when there's only one, when the quantity is 1. What happens if it's a single item with a quantity of more than 1? So is unit price times quantity of a single item. So look at the names of those tests. They're kind of explaining what the test case is. There's our basket again, but this time our unit price is 10. Let's make the quantity 2. So our, oops. So now, when we totalize this, we're expecting the total to be 20. Okay, let's rerun our tests. Now this test should be failing. Yep, we expected 20, but it's actually 10 because it's only returning the price of a single item. So again, we'll have to do something a little more sophisticated here. Let's do it quickly. Let's return the quantity. Oh, there we go. So now when we run that, all our tests are passing again. So we're back again on a passing test, which means it's time to think about the code, do a little code review. Well, I'm looking inside here, and there's a little bit of duplication here. We don't need to keep re-referencing that. So what I'm going to do is I'm going to extract this. Let's see if we can find the extract a variable, a local variable for this. So here we go. And let's replace both of them, get rid of the duplication. Let's call that an item, and it can be a const. That makes sense. And as soon as I do that, I immediately rerun my tests. Okay, so the code is a little easier to understand now. We've got rid of a little duplication. I'm reasonably happy with the tests. As you will see in later videos, there is something else we could do with these tests that might be useful. But I'm going to leave that for now because we need to get through this. I think we've got one more test case to think about. What happens if there's more than one item in the basket? Is the sum of times quantity for all items. Okay, so now we're going to have more than one item in our basket. So again, we can just be nice and easy, by 10 and a quantity of 1, do for the first one. And then maybe for, maybe for the second one, unit price of 20. And let's have a quantity of 2. Okay, and in this particular test case, we would expect the total of this basket to be 50. Okay, let's run that and see what happens. Okay, so expected 50, but it's actually just calculating for the first item as we would expect that it would. So let's go back to our shopping basket. Well, what can we do here? We can't just do it for one item anymore. So maybe what we need to do is we could do a for each. So if we have a total, which we set to 0 initially, and then in our basket, for each of the items, let's add to the total this. And then we just return total. Okay. And all our tests are passing again. Okay. So we now have a fully functioning totalized function, if you like, in the sense that it'll work for an empty basket, it'll work for individual items, it'll work for any quantity of item, and it'll work for multiple items. So I can't really think of any more test cases. So in terms of logic, we're done. I can't think of any more failing tests. But I'm looking at this particular code here and thinking, is there a more elegant way of doing this? Well, we could replace this with a reduce. So if, for example, we redo a total in an item, and at the end there, starting with a 0, and then just return that for the whole basket. So if it's empty, it should come out as 0, and if it's not empty, it should come out as the unit price times the quantity. Like so. Okay, that took a little long, but let's see if that worked. And it did, yeah. So it's more elegant now. It's simpler. We've got rid of all the nasty if statements and the for each and etc. etc. So I'm relatively happy with that solution. And I'm relatively happy with my tests now, that if I were to go back and change this solution, I would have sufficient test assurance there to convince me that I haven't broken it. So we've achieved a number of goals here. We've achieved a simple, elegant solution, and we've also achieved good test coverage going forward. So if anyone changes that code, we'll probably get very early warning that it's been broken. Okay, so that's test-driven development. Remember the microcycle. We start by writing a test that fails, and that describes something we want the software to do, something we want the code to do that it currently doesn't. And then we write the simplest code to pass that test. And then we stop and we review the code, and if necessary, we refactor the code, we clean up its internal design to make it easier to understand, to make it simpler, to remove duplication, and some other things that we will look at in later screencasts. So there you go. Those are the microcycles of test-driven development. See you on the next screencast.